Hello everyone. In this video, I'm gonna show you three good problems that are basically answers to some of the questions asked in my MATLAB programming class about plots. And I wrote some code to demo these for you. So the one is, if you have a plot, could you reverse the x-axis direction? Right? Or could you rotate the y-axis ticks, or could you rotate the label of the y-axis? Because if you do a regular plot, the ticks and the labels are all written on a horizontal line, and the direction of x and y is from smallest to the largest. So here I show you, I have plotted the function x sine of x for x between 0 to 20 pi 500 numbers. And I plotted, then I say set GCA, the current axis, x direction and reverse. That will reverse the direction of the x-axis. Then there is this new command called y-tick angle. Okay, and you can do it for x-axis as well, and you pass to it an angle, and then it basically changes the angle of the ticks of the y-axis. You can do it, as I said, for x ticks. If you want, you can rotate them, but it doesn't make sense. And this angle is counterclockwise positive. And also, if you want to rotate the label of the y-axis, so here you get the GCA y label. So first get the y label, whatever it is, in this case y, get that, right, which is y, and then do a rotation for it for 90 degrees. Okay, so instead of me just saying y instead of all of this, I'm saying get it from whatever the user is has defined, and then rotate it. And here is a title, right? So if I want to run this for you, look, here we go. You see your x-axis on the left is maximum, on the right is minimum. So the function, instead of going from left to right, is kind of going from right to left. Okay, and you see that the y ticks are all rotated 90 degrees, as well as the y label. Okay, if I don't do any of that, your plot is going to be like this. Look. You see, these are all the way they are. And this guy is already at 90 degrees, but if you want, you can go back and change that angle to 0 degrees, right? So 90 degrees is what it is, but these ticks, as you can see, they are horizontal. So the default for y is 90 degrees, but as I said, I can make it 0 degrees, right? So here, let me show you the difference again. Yeah, the correct thing is, if you want to see a difference, to make that angle 0, not 90. Because it is an absolute angle, not a relative angle here. So you see here, I kind of forced it to be horizontal, while it is not really what it is. Or you can make it 45 degrees or something, which is not really a nice thing to do, but you can do it if you want to. Another question they ask me is, if you have two functions like y1 x squared, the other one x cubed, between so much of x, like 0 to 5, could you highlight the area between these two curves, like you want to show the integral, right, of y1, y2 minus y1? Could you do that? Yes. So here I'm plotting the two functions on the top of each other with different colors, and then I need to use the command fill. Fill, what it does, it fills inside of a polygon. So you pass to it the x and the y of all of the vertices of the polygon. It draws that polygon for you, and then it fills it with a color that you specify. But the important thing is the order of these x and y. So if you start on a specific location, a specific vertex, it doesn't matter which one you start, but you have to go in a specific direction. So for example, let me show it in Microsoft OneNote. So the vector x and y that I pass for this rectangle, right, it has, if I start here and call this vertex 1, and then I choose a counterclockwise direction, then I have to go to 2, then go to 3, then go to 4. I should not sort it, and I cannot go 1, 2, 4, 3. If I do 1, 2, 4, 3, instead of shading inside this rectangle, it is going to go 1, 2, 4, and then go to 3, come back to 1. So you see, it is basically going to shade like this for you. Okay, if you go 1, 2, 4, 3 instead of going 1, 2, 3, 4. So you make sure you choose one specific direction, either clockwise or counterclockwise, doesn't matter. Start at one vertex, again, doesn't matter, and go back you don't need to go all the way back to itself. You go to the last but one, and it is going to connect them together, and it is going to fill inside of it, right? So you can make a hexagon, you can make a heptagon, you can make whatever you want. Or if it's a curve, you know your curve is not really a curve, it's a bunch of points connected by lines, right? So this is what you really have. And these are all connected by line like that. And now, if I just want to highlight under one curve, what do I do? Well, I need all of these points. Also, I need this point here, and I need these points projected onto the x-axis, or basically the x values that I used for my function. So I need these guys. So now that I have all of these points, if I start in the order and I go, it is going to connect all of these together, so you get this, and then it is going to what? It is going to highlight it for you. Yes? Now if you want it between two curves, so you also have another curve here, then instead of providing these x values or these x vertices and what? The vertices on the function, what you need is to provide the vertices on the first function and on the second function. So the top blue ones and these red ones. And then it is going to highlight only the area between them, like that. Okay, so the command fill does the job for you, and that's what I'm doing here. I say fill x and Philip left right of x, and then y1 and Philip left right of y2. What am I doing? Well, these are all of the x's, these are all of the y's, but the first part of the data is x and y1 here is the bottom curve. Okay, so the points that I'm passing are basically these red points. Then what do? I need to pass these blue points, but when I pass these blue points, remember, I went like this. I went like this, right? Let me use my marker, sorry. So I went like this, so now I have to come back. So I have to Philip my what? I have to Philip my data points in y2 and my x. Because when I come from here to here, I'm going backward in the x direction and backward along the curve y2. So I have to use Philip left right, which Philips the data horizontally, and that's what these two are doing. So these two together are this one and this one together form the points on the second curve or the top curve. And then I say fill between them with color C, which is for cyan. If you want, you can fill it with yellow or any other color. And then X label, Y label, and anything. So let me show you this part. There we go. You see? Again, each one of these curves is a bunch of lines. So it is really a polyline. Okay, it's a polygon. And I'm filling only between them, and very beautiful. Then another one that I saw somebody ask, and that is a good one, even it was mentioned on the MathWork website as a question. Somebody says, I have a parametric curve, let's say, for example, a spiral like this, and I want to show the value of the parameter t at some points on the curve. Well, you know MATLAB does not have such an option, okay? So if you plot a curve, right, let me just run this part for you. If you plot the spiral like this guy here, this data cursor or data tips, if you click, it only gives you the x and y, not the t that was used for x and y. So it's not going to show the parameter of a parametric curve. Now, if you want to show a bunch of points on the curve with their t-values, you need to use a loop. You need to use a for loop like this. So what I'm doing here, I'm plotting it, and then I'm going on a bunch of points, and on these points I generate a text which is basically t equals, and then with 4 places and 2 decimals, the value of t. So it's going to be t like t equals 0, t equal 1, t equal 1.6, t equal 2.9, and so on. And then I put that text on the curve using the text command. Now for the text command, you need to pass the x of that point, you need to pass the y of that point, and you need to pass the string. And here, to make sure all of the texts are on the same side with respect to the curve, I use this guy called horizontal alignment left. So put it on the left side of the curve. Put all of those texts on the left side of the curve. And you might say, what is this vec that you're doing here? Well, here I have used 500 data points to make that curve a smooth curve, okay? That curve is a smooth curve. If I use a few points, that is going to be very, very jagged and broken. But the thing is, if I want to show 500 t equals something on this curve, it's going to be very busy. So I don't want to use all of those points, okay? I want to use a lot less. And another thing is, when in the beginning the curve is small, I want to use fewer points, and as I get away from the center, I want to use more points, okay? Because I have more space to put something in between, but in this beginning, it's very small. You don't want to put a ton of text on the top of each other. So what I did is, from 1 to length of t over 2, every 20 data points, I choose 1 data point to put a value at. But after half of t to t, every 10 data points, I select and put a value in. And I combine these two together and call it vector, and now I find the x and y at the vector location and then do that. So basically what I'm doing with these 3 lines, I'm generating a vector which goes from 1 to 500 but without equal distance. So if you look at vector here, let me run this whole code so we can see, right? If you look here, you see here, if you look at the first loop, you see I have only what? I have only like 5, 6 points. But as I get on the bigger curves, you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have more and more. Okay, so as the space allows, I put more points on it, and you clearly see these are t's at different values on the curve, right? So if you look at the value of the curve, for me, you can see that, look, curve, what did they call it? Vector, call it vector. You see, they go from 1 to about 500, but the spaces are not equal. Look here, they are 20, 20, 20, 20, until here. Now it goes 10, 10, 10, because the curves are now big. So that's all I did in this code, and I showed you how to put those parameters on, and I also posted this code on MathWork website to answer the student's question. So hopefully it was useful to you. I'll see you in the next lecture. Thank you.